Good morning, everyone. So today let's work on another LeetCode quiz. Okay, this is a media question. Minimum number of operations to sort a binary tree by level. You are given the root of a binary tree with unique values. In one operation, you can choose any two nodes at the same level and swap their values. Return the minimum number of operations needed to make the value at each level sorted in a strictly increasing order. The level of a node is the number of edges along the path between it and the root node. Okay, so let's look at the example. This is a binary tree. The input 1, 4, 3, 7. Okay, so this is a BFS, breadth first search. Okay. The output is 3. Okay, what's our goal? Our goal is to return the minimum number of operations node to make the value of each level sorted in strictly increasing order. Okay, so as you can see in the original binary tree, each level, the second level is 4, 3, right? And it should be 3, 4. The third level is 7, 6, 8, 5. It should be 5, 6, 7, 8. Okay. So first step, swap 4 and 3. Secondly, swap 7 and 5. Thirdly, swap 8 and 7. Okay. Second example, this is a binary tree. Okay, also we use BFS to store the binary tree in the list. And swap 3 and 2. Step 2, swap 7 and 4. Step 3, swap 6 and 5. Okay. The last example. Okay. The output is 0 because each level is already sorted in increasing order, so just return 0. Okay. I guess I have some sense what we are doing here. And again, let's start from test the case to see whether we can find some generalized way to solve this problem. So the input should be let's say 5, 4, 3, 2, 1. Okay. So the tree may look something like 5, 4, 3. Two, 1. Okay. Okay, yeah. So this should be how the tree looks like. 5, 4, 3, 2, 1. If we directly look at it, we know we should be very straightforward. The output should be 2, right? So let's to see how we solve this problem, step by step. The first step is to use BFS to find its level and set level's value, right? Because what we input is a binary tree. Yeah, what we input is the root of the tree. So what we need to do is use BFS to find this level and set value. Let's say level values. That's what we want to do. Okay, so now we put everything in a list. It's easier for us to do, the following operations. The second step is to build a sorted box. So let's build a sorted box. So after we sort it, it should be something like this. And then we may want to build a mapping. Let's build a mapping. And the map is value to what? Value to sorted index. Make sense? It's literally a dictionary. So the key is 1, is 2, okay. So the value is a key, and the sorted index is a value. So that's a mapping. Then what do we need to do? We may want to build target array for the indices. Right? So when you build the target array for the indices, here it will be 4, 3, 2, 1, 0. And then we need to initialize the indicator whether they are visited or not. So visited should be false, 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 right? Anything else? If I is 0, then not visited. And target 0 is not 0. This is our target. So we should follow circle. From 0 to 4 to 0. Then what do we do? Update visited, right? Root is visited. Child nozzle visited. The leaf visited, right? So it should be target 0. Target 1. Right? Target 1. One, two, three, two, one. Then visited is updated. Visited, visited. Visited. And then target 2. Target 2 is 2. Target 0 is not 0. Target 1 is not 1. Then do nothing. And visited 2. Now we set it to as true as well. Right? Okay. Okay. So the total swap this level is 2. Okay. Oh. So our input is a tree was the root of the tree. Our return is the int. So do some initialization first. Total swaps start from 0. And if empty tree, right? If the tree is empty, then do nothing, right? Just return 0. Pretty straightforward. And then we need to initialize a queue for the breadth first search. So let's initialize a queue. DQ will construct an empty DQ. So basically it's a double-ended queue. Okay. Then put the root in the double-ended DQ. And then loop. Len bigger than 0, right? So as long as the length is big to 0, let's get the size of len. Make sense? And we also need to collect current level values in a list in left to right order. So level values put into a empty list. Then what do we need to do? We need to process every node in the current level, right? So process the every node in current level. So for anything in range, level size, right? And we should pop the leftmost node for first in, first out order of BFS. So node should be Q, pop left. And if left child exists, add it to the queue to process. If left child exists, add it to the queue. So if node left is not none, then what do we do? We put the left into the queue. And if right child exists, then add it to the queue as well. So if right child exists, add it to the queue. So here is node right is not none. Then put it into the right. Okay. Then we need to know how many elements we have for this level, right? So you know how many numbers in this level. If a level has only 0 or 1 element, then it's already sorted, right? So if level has 0 or 1 element, n is smaller than or equal to 1, then what we to do? just skip it. Make sense? And we can create a sorted version of level vowels. So sorted vowels. Sorted. Okay. And build a mapping from value to its target index. Right. So value to index. Let's build a dictionary. And enumerate, then we enumerate them one by one. So enumerate for index, for value. Enumerate sorted vowels. So what should we do? Value to index. Okay. So value is key. Index is a value. No. So here value is a key, index is the value. Okay. And then we need to build the target position ring. So target position. And then iterate over original indices. Iterate over original indices. I in range n. What should you? We should find target position for level vowels. I using the mapping, right? So we use target pose I value to index. Level vowels. Right. Then we need to use array to mark which indices have visited. All right. So visited. And count swamps recorded by counting circles. So swamp for each level. Then iterate over indices to find circles. Iterate over indices to find circles. And if already visited, already in correct position, then we just skip it. If already visited, if we already visited this node, just continue, right? Because we didn't find it. And also, if element is already in its correct position, which means that if the target position I is already equal to I, then mark this item as true, then just jump out. Make sense? And if not visited, then we need to traverse the circle, right? Circle, start of the circle, right? Follow the circle until we return. So we have visited J is false, which means we don't visit it yet. Then mark it as true. Then move J into the index. Okay. And then what we need to return should be yeah, the total swap. So let's go ChatGPT. Code bug. Okay. Oh, okay. I get the point. Fail to add it into the circle. Okay. Yeah. Try it again. And here, record the value. Okay. This seems works. Interesting. Okay. The time complexity is not available. Memory complexity is also not available. Okay. So as you can see, although the memory the difference is only 91.8 MB with 91.4 MB. But the difference is, but ranking is really different. Okay. And the time complexity difference is between 283 milliseconds and 239 milliseconds. Okay, I think what we can do here is let's explain the building functions, methods, operations, and provide a step-by-step visualized as the case in the worst case for the code. So from the test case, I think that the basic logic is straightforward. We check each level one by one. And the key trick here maybe firstly we need to use BFS to traverse the tree. Secondly, we need to use we use a dequeue here, which is double-ended queue to store the elements. Okay, so the building dequeue a queue with O1 push and pop at both ends, perfect for breadth first search. Then X, size of queue or list. Used to know how many nodes are in the current level and to bound loops. Sorted. Return a new sorted list, ascending by default. This is a target ordering for a level. Enumerate. Here's index value. Used to build value to index quickly. Dictionary. Maps each value to its index in the sorted array. And these indicators we're using. Level vowels is to connect value at each level. Target position is to pre-allocate an array of length n. Visited to track cycle visitation. Comparison. If root is none, empty tree, faster path. If node left is not none, guard before NQ. If visited is true, and well visited J is false. Cycle, traverse bookkeeping. If target position I is equal to I, recognize items already in correct position. Okay. Okay, so here is a step-by-step visualized example. So the level value here is 54321. And we sort it into I think here is much. Okay, so visualize the circle. So we start from index. The index is 0, and our target position I think that the picture should be much straightforward. So the indices is 0, 1, 2, 3, 4, right? The current value is 4, 5, 4, 3, 2, 1. But after we sort it, the index should be 4, 3, 2, 1, 0. Make sense? And then we may find Q is good here, but we need to swap 4 and 0, swap 1 and 3 to make the sorted index, to make the original indices. How do you pronounce indices or indexes?
Indices.
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 Indices. Indices. Okay. So for level of n distinct values, the worst case for swap is one big cycle of length n, okay, which cost n minus 1 swaps. A simple way to get a single circle is to rotate a sorted array by 1. So the sorted values is 1, 2, 3, 4, 5. Then we can use level vowels 2, 3, 4, 5, 1. Left rotate by 1. Then value to index. Target position. Then value to index is 1, 0, 2, 1, 3, 2, 4, 3, 5, 4. And target position 1, 2, 3, 4, 0. Target position is 1, 2, 3, 4, 0. The circle work is one circle of length 5. 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 0. Then the swap will be 4. That's the maximum swap. So if you build a tree with one level have values 2, 3, 4, 5, 1, then the algorithm will count 4 swaps for this level. But you only need the BFS visits that level in the listed order. Okay. So for full BFS visual. So at the very beginning, so suppose a tree. I think that the demonstration is still not clear enough. For your test case, in the worst case, please for each step draw a visualized binary tree to show how each parameter change. Okay. Yeah, I think that most of the time, when we try to explain the algorithm, we need to, draw the pictures on a whiteboard to show how each parameters change. And using ChatGPT will help us to do this much better. Okay. So let's visualize it. So we start from this one, this tree. Okay, we only care about one BFS level contain this part, because we don't care about what's the root, right? Root just had itself, so nothing changed. We only need to care about the level 2 and the level 3. And for level 2 and level 3, the sequence is 2, 3, 4, 5, 1, none. Make sense? So level 0 is 10. Level 1 is 2, 3, 4, 5, 1, and none. That's our focus. Level 2, just ignored. But hey, let's build a tree, which is, I think this doesn't align with my example here. And then let's build a tree. Well, okay, yeah. So now this is how the tree looks like, right? So it should be, yeah. Yeah, same thing as I mentioned here. This is how it looks like, right? When we do BFS, to put it in a list, it will be 5, 4, 3, 2, 1. Okay? Root is 5, level 1 is 4, 3, level 2 is 2, 1. Okay? So we will simulate the Q evolution. So firstly is to initialization, right? The Q is 5. The total swap is 0. Then we enter level 0, which basically is a which basically is the root level. The level size is 1. We pop 5. And the append is children. So NQ for 3. Level of vowels is 5. And because the size is just 1, so no swaps. After level 0, the Q will be for 3 because for 3 is children, right? And we needn't to do any swap. Then we go to level 1. For level 1, what we have is 4 and 3. So for load 4, the children is 2, 1. And the level of vowels is 4. So after pop out, the Q will be 3, 2, 1. Make sense? Because we add 4's children after 3. So the Q will be 3, 2, 1. And the next step, the load is 3. It doesn't have any children. And the level of vowels will be for 3. And the Q will be 2, 1. Okay, so yeah, this is literally what we are talking about here. The level of vowels is 4, 3, because now we go to the first level. The sorted vowels should be 3, 4, right? And the value to index will be 3, 0, 4, 1. What does it mean? It means that for index 0, the value will be 3. And for index 1, the value should be 4. And our target position is 1, 0. Right? So the circle basically is about the rotation. So I think that we can ask it explain. What does circle mean? Okay, so the question is how many swamps are needed to transform level vowels to sorted vowels, right? The first step is to build the mapping. And here we assign every element to its sorted index position using a dictionary, right? So for sorted index 3, the value 3 should have a index at 0, 4 have an index 1, right? Then we replace each value in level vowels with its target position. So as you can see, for value 4, the original index is 0. But we hope our target is index 1, right? For value 3, original index is 1, and we hope the target index or sorted index is 0. So target position will be 1, 0. Make sense? That means the element currently at index 0 should go to position 1, and the element currently at index 1 should go to position 0. So the second step is that now think that this target position value as permutation mapping. What does permutation mapping means? Okay. Each index points to where its element should go. Let's follow index 0, right? So we start at 0. From 0 to target position, 0 is 1. And 1 will go to its target position 1, which is 0. Then back to start. That's a circle. You've looked back to where you started. So to visualize this is that in indices 0 and 1 belong together. The element 1, element at 0 is sitting where 1's element should be, and vice versa. So why a circle means swamp? For any circle of misplaced elements, if the circle's length is 2, you need 1 swamp. If circle's length is 2, 3, you need 2 swamps, so on and so forth. Makes sense? Right? Imagine a circle. No matter how many elements it should be. Let's say if 1, 2, 3, or let's say 1, 3, 2, right? Or 1, 2, 3, 4. No matter how many elements you have in a circle. Let's say, for example, we have 2, 3, 5, 1, right? So if we want to make it increasing, then it should be 1, 2, 3, 5, right? This can be achieved by rotate, or make it even a little bit more complex. So you should be 1, yeah. For example, can we swamp to sort? Okay, so if we want to swamp this one, firstly, we swamp it as 1, 3, 2, 5, 1. So which means we only swamp the first 4 letters. And then we swamp it as, then we swamp in for these 3 letters 2, 5, 3. Then we swap these three elements 2, 3, 5. And then we swap these 3 numbers. It will be 3. Wait. Then the last 3 elements. Okay, swamp 2 and 1. And then swamp 3 and 2. Swamp 5 and 3. Swamp 7 and 4, 6, 7, 6 and 7. Swamp 8 and 7. Okay. Okay. Yeah. So to summarize, circle 0 to 1 to 1 to 0 mean when we trace, well, each element should go to be sorted. Start from the index 0 leads us through index 1 and back to index 0 again. So those 2 elements are in each other's place. And we can fix them with single swap. Okay, because when I am in your position, you are in my position. Then we just, then it will be just one swap. Okay, so let's go back to the original algorithm. Yeah, circle length is 2, then it's 1 swap. And then we go to the second level. The swamp for this level is 1. The total swap will be 2 because Yep. We have one spot at level 1, we have one spot at level 2. Then we just output 2, right? Yeah, this is a visualized. For level 0, we only have one value 5, no swamp needed. For level 1, we have 4 and 3. And after sorted, it should be 3 and 4. So the circle is from index 0, go to index 1, then go to index 0, then it's one swamp. And for level 2, we have 2 and 1. Then the sorted sequence will be 1, 2. And the circle will be from index 1, 0 to index 1, then go back to index 0. It's one swamp. And then we add them together, so the answer should be 2. Yeah, I think that's pretty much for this question. And yeah, thank you. Bye.